Hello and welcome to the ACAT tutorial. GPX uses the advanced compartmental absorption and transient model to describe the oral drug in vivo behavior. The whole gastrointestinal system has been divided into 9 compartments. Each compartment has been divided into 4 subcompartments: unreleased, undissolved, dissolved, and enterocyte. Drug is considered to be absorbed in GPX when it enters the enterocyte. Drug absorption can be passive based on the concentration gradient across apical membrane, or it can be mediated by influx and efflux transporter in the enterocyte. In this tutorial example, we will optimize the absorption scale factor ASF model for the compartment absorption. So for this example, the compound already have all the model parameters except the parameters related to absorption, such as permeability, PEF, or the ASF of each gut compartment. So that's the absorption scale factor. Let's first run a simulation of a 100 milligram tablet administration, which with the default ASF model. From the analysis view, we can find the predicted plasma concentration profile is lower than the observed data. If we click on the regional absorption, we can find that 2.7% has been absorbed from cecum, and around 12% has been absorbed from ascending column. The total absorption of the dose is around 64%. So we can find from this plot, the compound are not completely absorbed. There are around 40% haven't been absorbed. What's the reason? If we click on absorption and the dissolution, we can find the compound is dissolved very fast, as shown by this red line. So the incomplete absorption is mainly due to the absorption model. So we need to calibrate the absorption model for this compound. Let's check the absorption model of the ACAT model. Click on the physiology view, and under the gastrointestinal panel, it lists all the physiological parameters of each compartment for the ACAT model. If we go to the bottom, we can find it lists all the parameters like a pH, transient time, the length, radius, the biosalt concentration. These default parameters are provided by the software based on the subject we created. Like for this subject, we created it is a human subject, 28 years old, 82 kilogram. It also under fasted conditions. In this panel, it also shows the model we select for absorption scaling factors. For this model, we select the optimized log-D model. For these log-D models, the ASF of each gut compartment are calculated based on the absorption gradient coefficient, C1 to C4. It is not convenient to directly change the ASF of each compartment. So in this example, we will optimize these 4 parameters of the ASF model. So these parameters will regulate the degree that log-D can influence ASF. C1 and C2 are parameters that will affect small intestine. C3 and C4 are for large intestine. So if we change any of these parameters, it will change the ASF value for each compartment. The next step, we will try to optimize the ASF model. Go to the runs view. Now we want to create a run for this optimization process. First, set the run type to optimization and give it a name. Click on OK to create the run. We will also include the 100 milligram pill tablet simulation for this run. Now we already create a run for the optimization. Go to the simulation setting this panel, move to the search window under the optimization parameter selection subpanel. We will select C1 to C4 for optimization. First, we will search these parameters, type optimized log D. Now we can find C1 to C4 has been shown in this parameter tree. Select these 4 parameters. The program will provide the upper bound and the lower bound, these constraints for these values. In this example, we will use the default value. You could also able to change these constraints. Go to this observation selection and weight subpanel. Because the parameter optimization is against the observed CP time profile. So we will select the observed data, observed CP profile by click on the systemic circulation. We will keep the default weight as 1. For the objective weighting functions, we will keep it the default 1 over y hat square. So now, until this step, we already set up the objective function. We already set up the parameters we're going to optimize. Now we go to the run control subpanel and click on start. After click on this start, the optimization process will start. Now we can find the R square of this optimization process has been increased from 0.6 to above 0.9. That means the optimized parameters give a better match to the observed data. You could, if you satisfy with the R square, and you can click on stop even earlier if you don't want to wait longer. Let's just click on stop to finish the optimization. When the optimization finished, the analysis will display all the optimized parameters. For C1 to C4, it's provided the values, both the initial value and also the optimized value. We can find the C3 and the C4 has been significantly, especially the C4 has been significantly increased. On the right side, it also shows the predicted PK profile optimized model. It matches the observed profile. If we like this result, you can transfer these parameters to update the ACAT model. Let's click on transfer of each parameters. And also the message center also shows the information that these parameters has been updated. Now let's click on done to remove this information. Now we can go to the physiologist view again. Now we can find the ascending column. The ASF has been significantly increased. This is due to the increased value in the C4. This is due to C3 and C4 are correlated, are the parameters related with the colon compartment. Now we can run a simulation again with this optimized ACAT model. After this simulation, we can click on the CP time profile. It shows a better match between the simulated PK profile and then the observed profile. If we click on the region absorption, the new model shows 21% absorption from cecum and 32% absorption from colon. Also, the total absorption is very close to 100%. It's around 98%. So it's almost complete absorbed. It's just a short summary through this example. We just want to show the process to optimize the ASF model for the absorption model in ACAT. And in this way, we better describe the absorption process for this compound. Thank you.